Good morning, everyone. It is day 4, or actually I should say good afternoon because that's when you're going to see the video. Okay, once again, it is day 4 of online learning. You guys are doing an excellent job, so keep it up. We're almost done with our first week, so keep that up. One thing, definitely forgot to show you guys my picture yesterday. I didn't get a chance to start it because I forgot, but I did start one today, and of course it's a Disney character. It's Scar. Now, the reason I'm telling you is because it's on this paper. Now, if it said mystery puzzle, then I wouldn't tell you, but I'm telling you now, okay? And the reason I keep doing Disney characters is because Mr. B loves Disney. He used to work there, remember? Okay, so I'll show you guys what that looks like later today, but first, let's get into a FlowCap video of telling time to the hour and half hour, and then we'll jump into our morning work.
I know this bee named Ben, and she's really busy. I don't know how she does it. I'm gonna ask her. Yo, Ben, how do you do it?
I'm Ben the bee. I'm busy every single hour. I start at 9 o'clock when I pollinate flowers. Honeycomb club at 5:30. Oh my busy schedule means I need to tell time. I know how to tell time to the hour. It's easy to do, man. It's not a superpower. He's an analog clock I'm always enjoying. I ask myself, where is the hour hand pointing? Right now, it's aimed directly at 9. Now look for the minute hand and see what you find. It's pointing to the 12. Look at that. The hour is exactly 9. 0 minutes past. Another way to say that is 9 o'clock. That means exactly on the hour, not a minute off. Cause the hour hand points right at the number. The minute hand points at 12 with all its muscle. We can write it out like this, 9 o'clock. Or we can write it out like this, 9 o'clock. Or we can write how it looks on a digital clock. The number 9 and a colon, that's 2 dots. Then 00, which means exactly on the hour. Now tell me the time. Go ahead and shout them. What time is it? 11 o'clock. Said what time is it? 3 o'clock. Tell time to the hour. Here's the way the hour hand points at the hour of the day. The minute hand points directly at the 12. Busy, 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 busy. So much time to tell. Tell time to the half hour. It will do wonders. The hour hand points in between 2 numbers. The minute hand points directly at the 6. Busy, 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 busy. Now you know the trick. Telling time to the half hour is fun to do. An hour is 60 minutes, so let's split that in 2. The clock is a full hour, so if we split it, each half will be exactly 30 minutes. We tell time to the half hour every day. The hour hand will be between 2 numbers halfway. Here it's right between 1 and 2. There's your clue. It's after 1 o'clock, but it's not quite 2. That means the hour is 1. Let's look at that more. We use the number it's after, not the one before. And where is the minute hand? At the half hour, pointed at 6. Perfectly downward. That's 30 minutes. 1:30, the minute hands at 6. When the hour's half done, the time is 1:30. That's one way to say it. Or 1:30 if you want to rephrase it. What time is it? 3:30. Said what time is it? 5:30. Time for Honeycomb Club. Yeah. Time for Honeycomb Club. Yeah. Tell time to the hour. Here's the way the hour hand points at the hour of the day. The minute hand points directly at the 12. Busy, 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 busy. So much time to tell. Tell time to the half hour. It will do wonders. The hour hand points in between 2 numbers. The minute hand points directly at the 6. Busy, 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 busy. Now you know the tricks.
All right, I hope you guys enjoyed that FlowCap video on telling time to the hour and half hour. Now we're gonna jump right into our math morning work, okay? So number 1 says, which of the following has a capacity that is closest to 1 liter? Now when we're thinking about capacity, we're thinking about that liquid items here. So I'm thinking about milliliters, I'm thinking about liters. Now in this case, it's asking the question closest to 1 liter. So first thing I want you to do is I want you to think about your options that you have. So we have an eyedropper, we have a small coffee cup, we have a medium-sized bottle of water, and we have a bathtub. Let's start from the bottom and then work our way to the top. So D says a bathtub. We know that would be much more than a liter. Let's skip over C and go to D. It says a small coffee cup. Now, small coffee cup means we're gonna have a little bit of liquid, so that's milliliters here. And then we have an eyedropper. We know an eyedropper is definitely milliliters. So when we resort back to C, we have a medium-sized bottle of water that has a capacity that is closest to 1 liter. So our answer is C, a medium-sized bottle of water. Okay. Our next question says, when rounded to the nearest $10, a toy robot costs $80. Which could be the actual cost of the robot? Now, when we're thinking about our options, we need to go through our list and figure out which ones are meeting that rule of 5 or more, raise the score, 4 or less, let it rest. So when we look at those options, let's start down from the bottom and work our way to the top. So D says $86. We know that wouldn't round to the nearest 10 to 80 because we know that would round to 90 because we have that 6 in that ones place. When we take a look at C, we have 85. Would that round to 80 to the nearest 10? Nope, because we have that 5 and we have that 5 there. We know that 5 or more rule, okay? Taking a look at option B, we have $75. We know that when we look at that 5 in the ones place, we know that's going to tell us to raise the score. So we're going to raise it up to 80. So our answer is B, $75 would round to the nearest 10 to that cost of $80, okay? All right. Number 3 says, which of the following is the missing number in 72 divided by blank equals 9? Now, when we're thinking about this, we should be thinking about multiplication and division facts here, as well as our fact family. What could be in the same fact family with 72 and 9? And our answer is 8, because 72 divided by 8 equals 9. 9 times 8 equals 72, okay? Next question says, which of the following describes the shape? Select all that apply. Now, first things first, we know that it has 4 right angles. Next thing we know is that we know it has 2 pairs of parallel lines because parallel lines keep going and they never intersect. Now, parallel lines can also be like this as long as they never intersect. So parallel lines keep going and they never intersect, whereas our perpendicular lines that we discussed, which we are discussing right now in this case, but perpendicular lines, just for a refresher, they always intersect. Now, so we have 4 right angles. We have 2 pairs of parallel lines, sides. So let me show you exactly what that looks like actually. Give me just a moment. Just want to show you what they look like. Now, when we're talking about 2 pairs of parallel lines, we know that pair means 2 of something. So if we have 2 pairs, that means that there's 4. So I'm going to show you exactly what the parallel lines look like as soon as my pen decides to work. Right. Let's try it now. There we go. Okay, so we have parallel lines going straight up and down on this side and parallel lines going straight up and down on this side. And where do you think the other parallel lines are? Parallel sides are right here, okay? So parallel lines here and here, those lines would never cross. And then we have the ones going straight up and down, those lines would never cross, okay? Now I'm going to erase so I can show you one more thing because there's one more description that fits all of these. Okay, now when we're thinking about the next attribute that fits this shape, the rectangle, we are also thinking about a convex polygon here. So convex polygons, in case you don't remember, they are describing vertices that are pointing outwards. So when you draw a star, which I can't really draw a star with my fingers, but if you were to draw a star on your paper, you know that the vertices on a star would point outwards. And for those that need an example of what vertices are, I've already put the dots on where the vertices are on this shape specifically. So they are the edges, where the edges meet, and they are the points on each shape. So I've counted 1, 2, 3, 4 in orange for you right there. And once again, remember those vertices that point outwards, those are your convex polygons. So if it is pointing outward like a star would, that would be called a convex polygon, okay? I'm going to move to the next. All right, our next question says, Cho, interesting name. Cho ran for 15 minutes, walked for 22 minutes, and then biked the rest of the time she spent exercising. Cho spent 65 minutes exercising. So we know our total time that was spent was 65 minutes. It says, how much time did she spend biking? Draw a bar diagram to show the problem, then solve. Now, as I told you, you don't always have to draw a bar diagram if they ask you to. Sometimes we can just do this on our paper using simple subtraction. We don't need a bar diagram to do that, okay? So it says 15 minutes, walked for 22 minutes, and then biked the rest of the time she spent the rest of the time exercising. So we know that we have 15 minutes so far that was spent, plus 22. I know that I'm gonna add 15 plus 22 because if it tells us 15 minutes at first and then walk 22 minutes, those are 2 separate times here. Okay, so we have 15 plus 22. 1 plus 2 equals 3. 5 plus 2 equals 7. Okay, So that's how many minutes that Cho has spent so far exercising, because it said 15 minutes, then walked for 22. And then they didn't tell us the rest of it. They said the rest of the time she spent exercising. Then they left it there. Then they told us the total amount that was spent was 65 minutes. So we know that we need to do 65 minutes that was spent total minus the 37 that we know that she walked, okay? So 65 minus 37, let me make it bigger for you, please, really quick. 65 minus 37, okay? We have 65 minus 37. Now, clearly I cannot do 5 minus 7, so I need to make that 5 a 15. And what needs to happen to that 6? I need to make it a 5, okay? 15 minus 7 equals 8. 5 minus 3 equals 2. So my answer is 28, but not just 28. I'm going to go back to my question. It says, how much time did she spend biking? She spent 28 minutes biking. Okay. All right, next question. Marcy spent 2/3 hour completing her science homework and 3/4 hour reading her homework. Write a comparison statement using greater than, less than, or equal to. Use a number line if necessary. Now, in this case, you may need to use a number line, but in this case, I'm going to show you the fraction strip that I have with me, as you've seen for the past 2 days. So we're going to use a visual here. So if we're comparing 2/3 versus 3/4, we need to make sure that we line it up on the fraction strip as I did for you. Some of us already remember our equivalent fractions and fractions that are greater than or less than or equal to just by looking at the fractions, comparing the numerators versus the denominators. But for those that need a visual, I have my fraction strip here, okay? So one thing I did is I made sure that I circled 3 of the 4ths, because it said 3/4 hours she completed reading her homework, okay? So I circled 3 of the 1/4, and then I circled 2 of the 1/3 because it said she spent 2/3 hour completing her science homework. And then I made sure to line it up. And now taking a look with that visual, I can see which one is greater. And clearly 3/4 is greater than 2/3, okay? So that would be my comparison, right? Next question says, Laura calculated 342 minus 258 equals 84. How could she check her answer? What will she find? Now, we're gonna go over the how could she check her answer part. Now, she got 342 minus 258 equals 84. That means if we do subtraction to solve the problem in the beginning, we can use addition to recheck the work at the end, okay? So we can do 84. Gonna make some erasing here, okay. We can do 84 plus 258 to make sure that it would equal to 342. So 8 plus 4 equals 12. I'm gonna put down my 2. I'll carry my 1. 1 plus 5 equals 6. 6 plus 8 equals 14. I put down my 4. I carry my 1. 1 plus 2 equals 3. Okay. Did it equal 342? Yes, it did. So that's how I could check my work. I can use addition at the very end to solve for that beginning number. Okay. Number 8 says Skylar left her house at 18 minutes to 3. Draw hands on the clock to show when she left. So when we're taking a look at a clock and we're trying to draw hands, such as the minute hand and the hour hand, and it tells us it's 18 minutes to 3, we know that our minute hand, which is the big hand, should be on the exact 18 minutes. So that would be in between the 3 and the 4. We know that the 4 represents on the clock 20. So we need to be 2 minutes before with that big hand when you've drawn your clock, okay? Now, when we're drawing for 18 minutes to 3, we know that it's almost 3. So we know that the hour hand, the small hand, should be in between the 2 and the 3, okay? And eventually, when it keeps turning, it will get all the way to 3 o'clock on that part, okay? And that concludes our morning work for today. Stay tuned for independent work later on.
Yo, my name's Miyachi, I got something on my mind. I have a few questions and they're all about time. It started one day when I was coming home from school. My father wrote me a message so I could make some food. Yum. He wrote the note in detail, telling me the rules. Put lasagna in the oven at 5:30, but don't snooze, and heat it 50 minutes, and then after take it out. Yeah. But when I put it in, I started thinking about how I need to figure out if I put the lasagna in at 5:30 for 50 minutes, when does it finish? I sat and thought a minute. I really didn't get it, cause 50 plus 30 is 80, but 80 don't fit in. There's only 60 minutes that's inside of 1 hour. We must calculate before the lasagna becomes brown. I thought, oh, I could just use the number line. Add the time in 10-minute intervals and I'll be fine. So 5:30, 5:40, then 50. But add another 10 at 6 o'clock, not 60. And then we get 6:10, then 6:20. And now I know what time the lasagna should be ready. Yeah.
I never thought I'd be singing, but now I'm feeling so fine. How much time has gone by? That's the elapsed time. I never thought I'd be singing, but now I'm feeling so fine. How much time has gone by? That's the elapsed time.
I got another problem and it's different than the last time. We gotta solve it by finding out the elapsed time. My friend Kevin, he's got his tuba lesson. It starts at 7:30, he's done by 9:07. So how long did his lesson last? Let's use a number line, break it down and do the math. We start at 7:30, need to get to 9:07. Okay, what's the biggest unit we can use so we can get there? 1 hour. We add 1 hour, 7:30 turns to 8:30. Now we got a little more time to get to 9:07. Add another 30 minutes and we get to 9 o'clock. Now we got an hour, 30 minutes with a little left. Jump another 5 whole minutes. Yeah, it gets us up to 9:05, we aren't finished. Oh no. Add another minute, now it's 9:06. Yeah, one more, it's 9:07, and we did it. Yes, count it up. 1 hour plus 30 minutes plus 5 plus 1 plus 1 equals what? 1 hour, 37 minutes equals how much time elapsed into a lesson and Kevin was done.
I never thought I'd be singing, but now I'm feeling so fine. How much time has gone by? That's the elapsed time. I never thought I'd be singing, but now I'm feeling so fine. How much time has gone by? That's the elapsed time.
I'm that lasagna that everybody wants to eat. And Kevin's tuba lessons are so long. I can't believe how much you paid for those 1 hour, 37-minute tuba lessons, Kevin. You know, other instruments are way more portable and more appropriate for a little kid your size. Crazy, Kevin. Take it from me. I'm a lasagna, so I know the stuff.